No, I'm pretty sure this is the last one. Wait, let me double check. No, it's still what now on module 13? Alright, you're almost there. Virtual environments and packages. Introduction. Python applications will often use packages and modules that don't come as part of the standard library. Applications will sometimes need a specific version of a library because the application may require that a particular bug has been fixed, or the application may be written using an obsolete version of the library's interface. This means it may not be possible for one Python installation to meet the requirements of every application. If application A needs version 1.0 of a particular module, but application B needs version 2.0, then the requirements are in conflict, and installing either version 1.0 or 2.0 will leave one application unable to run. The solution for this problem is to create a virtual environment, a self-contained directory tree that contains a Python installation for a particular version of Python, plus a number of additional packages. Different applications can then use different virtual environments. To resolve the earlier example of conflicting requirements, application A can have its own virtual environment with version 1.0 installed, while application B has another virtual environment with version 2.0. If application B requires a library be upgraded to version 3.0, this will not affect application A's environment. They're like little separate little worlds, little bubbles. Bubbles inside the bubbles. Creating virtual environments. The module used to create and manage virtual environments is called VENV. V-E-N-V, virtual environment. Fuck me running. I fucked it all up. Oh, it's all kind of shit. Shit. Alright. The module used to create and manage virtual environments is called VENV. Already said that. VENV will usually install the most recent version of Python that you have available. If you have multiple versions of Python on your system, you can select a specific Python version by running Python 3, or, whichever version you want. It's done. To create a virtual environment, decide upon a directory where you want to place it, and run the venv module as a script with a directory path python -m space -m space venv space tutorial -env. Though of course the tutorial part is optional. That's just that will create the tutorial-env directory if it doesn't exist. And it will also create directories inside it containing a copy of the Python interpreter and various supporting files. A common directory location for a virtual environment is .venv. This name keeps a directory typically hidden in your shell, and thus out of the way while giving it a name that explains why the directory exists. It also prevents clashing with .env environment variable definition files that some tooling supports. Once you've created a virtual environment, you may activate it. On Windows, run tutorial, in this case, right, -env, /scripts /activate. On Unix or Mac OS, run source tutorial -env /bin/activate. Now this script is written for the bash shell. If you use the CSH or fish shells, there are alternate activate.csh and activate.fish scripts you should use instead. Google is your friend. Activating the virtual environment will change your shell's prompt to show what virtual environment you're using, and modify the environment so that running Python will get you that particular version and installation of Python. For example, say if we did this, it'd be like that. To deactivate a virtual environment, type deactivate into the terminal. Managing packages with pip. The Python. Wait a second. What does pip stand for if Python package index is PPI? You can install, upgrade, and remove packages using a program called pip. this is really neat and fun to do. If you haven't done that yet, I recommend it. By default, pip will install packages from the Python package index. You can browse the Python package index by going to it in your web browser. Pip has a number of subcommands: install, uninstall, freeze, etc. Consult the Installing Python Modules guide for complete documentation for pip. You can install the latest version of a package by specifying a package's name. Like in this case, you can, you're specifying in this case the directory and everything, but otherwise you don't have to do that. You could just write in Python. And by the way, the $ in these examples, you don't put that in to the command line when you're typing it. This is just a placeholder in examples. It's supposed to mean like this is at the prompt, right? But you don't type the $. Python usually, but it would depend. I don't. It's not. I say fuck. Python -m pip install novas would in this case collect and download novas, and that's literally it's so neat. You can do this, Pygame. Lots of external libraries allow you to do this, where you can just type in a few words into the command line and or bash, whatever you're using, and press enter, and it'll collect everything, install it. It's pretty cool. You can also install a specific version of a package by giving the package name followed by == and the version number. So in this case, we will get requests version 2.6.0. It'll do the same process. If you rerun this command, pip will notice that the requested version is already installed and will do nothing. You can supply a different version number to get that version, or you can run python -m pip install -- upgrade to upgrade the package automatically to the latest version. So in this case, since they downloaded an older version, they just install -- upgrade of requests, and it will automatically get them from 2.6 up to 2.7. And otherwise, like if you try and install it twice, it'll just say, this is already installed. So it's very convenient. Python -m pip uninstall followed by one or more package names will remove the packages from the virtual environment. -m pip show will display information about a particular package. Pip list will display all of the packages that you've got installed in your virtual environment, in the given virtual environment. Like here, they've got all this external libraries and whatnot. -m pip freeze will produce a similar list of the installed packages, but the output uses the format that pip install expects. So a common convention is to put this list into a requirements.txt file. By, again, pip freeze and then put the output over to this file that you named requirements.txt. Then if you wanted to check later that file, it will show you the output of the freeze. The requirements.txt can then be committed to version control and shipped as part of an application. Users can then install all the necessary packages with just the command install -r. It's really cool. Pip has many more options. Consult the Installing Python Modules guide for complete documentation for pip. When you've written a package and want to make it available in the Python package index, consult the Python packaging user guide.